Hi friends, today's topic of discussion is a numerical problem for the subject Metrology and Quality Control, and chapter is SQC. So the problem was asked in summer 2014. The problem is as follows. Number of defects found in a inspection of 10 assemblies are 2 defects are found in one of the assembly, 3 defects were found in the another assembly. So like that, 2, 3, 2, 5, 2, 3, 5, 3, 0, 1 respectively. These are the number of defects which are found in an inspection of 10 assemblies. Then draw appropriate control chart and conclude. Here it is not given which type of control chart has to be used, but since here number of defects are given, we will use C chart. Additional information: C chart shows number of defects or non-conformity in an inspection unit such as automobile casting, cloth, etc. So here we will be using C chart as the number of defects are given. So here first we need to find the central line. Okay, so the formula for finding central line is number of defects divided by the total number of inspected items. So here the number of defects, if we want to calculate, what we need to do, individual defects in the castings, or here in case it is given as assemblies, so that we need to add. So 2 plus 3 plus 2 plus 5 plus 2 plus 3 plus 5 plus 3 plus 0 plus 1. So these are all the defects which were there in the assemblies, individual assemblies. So that we need to add because we want total number of defects, and then we have to divide by total number of inspected items. So total number of inspected item were 10. So we got C bar, that is the central line, as 2.6. Once we get the central line, now we need to calculate the control limits, okay, so that we know whether the process is under control or not. So here control limit, so this is UCL, okay, upper control limit. So C is equal to C bar plus 3 root of C bar. So here we will put the value of C bar, which we got as 2.6, and then we will get upper control limit, okay, as 7.43. Then we need to calculate the lower control limit, so that is equal to C bar minus 3 root C bar. So we put C bar value, which we got earlier as 2.6, and the value we got as minus 2.23. This we will take equivalent to 0, because all our values that are defects are above 0 or above 0, so we will not go below 0. So here what we have done, instead of minus 2.23, we have taken it as 0. Okay, so then step number 4, we need to draw the C chart. So in C chart what we will do, we know the central line or C bar, and we know the upper control limit, and we know the lower control limit. So here on the x-axis we will take subgroups number or the assemblies, and on the y-axis we will take number of defects. So here we have upper control limit as 7.43 and lower control limit as 0, because it was minus, so we took it as equivalent to 0. So now for the first assembly we got the number of defects as 2. For the second assembly we got the number of defects as 3. So these defects what we got, here we need to plot, and then finally after plotting we need to join it with straight line. So here we are joining all the plotted points with straight line. Okay, so here the 7th assembly have the number of defect as 5. So here all the defects we are joining with straight line. So here we have the 9th assembly where the number of defect is 0, and then okay, so here we can see all the number of defects in individual assemblies, and that we have joined with straight line. Okay, so now we have plotted all the points, that is This is the number of defects in assembly number 1. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the number of defects we have plotted. Okay, and finally we need to conclude. So the conclusion is that all the points lie between the control limits, hence the process is in control. So what we see that all the points which we have plotted are between the control limits, hence we can conclude that the process is in control. So this was a numerical problem, okay, for the subject metrology and quality control, and the chapter is SQC, and this problem was asked in summer 2014. Hope you liked the video. We will again meet in the next video very soon. Till then, goodbye.